Yo, sup homies, how y'all doing? Today we got the fixed point method representation of signed real numbers in binary using C program. So let's begin. We're gonna break this code quick. We got a fixed point function. Basically this function right here takes a number like a float number or like a double number as input and the number of bits as input. Basically the principle behind this function is that it divides the float like double number into two parts, an integer and a fraction. We're gonna divide it using the mod f function. So first you separate the double number into two integer numbers using the mod f function. We got many like types of mod f function. We got the mod f for doubles, the mod ff for floats, and basically mod f is modulus and functions. Simple as that. Next up, you basically just take the first integer parts and you transform it, like you convert it into binary, the same as the other methods, you know what I'm saying, bro? The second main key is the fraction part, you know what I'm saying? And to like acquire the fraction part, you basically you keep dividing, like multiplying by 2, and then you get a value, and then you take the the number from up to down below. Next up, we print the binary value. We start with the integer part and then we print the dot, like the binary point, and then you print the fraction part. Simple as that. We have another function of bool type. Basically this function is for the input. It's like it's designed for checking if the input is basically floats, you know what I'm saying, about like negative numbers or like everything. Now the main function is simple, like just combine all of that together, and once again you check the input of the user if it's float or like a double number or not. So let's check, like let's test this out. Fixed point, basically type a float number, for example 9.5, and type number of bits 16. As you can see, 8 bits goes for the fraction part, 7 bits goes for the integer part, and 1 bit goes for the MSB. Anyways, thank you homies for watching, and I'll catch you in the next one.